Yo, what's up guys? So let's try to do this integration question. So 1 over 4 plus 5 cos x. This one, it looks really unassuming. Like it doesn't look that difficult, but it's actually quite a bit of work for this guy. And we're going to need to use something called the T formula. Okay, so for cos, so if we have t equals to tan theta on 2, then we have cos theta being 1 minus t squared on 1 plus t squared. Okay, so hopefully we know at least something about the T formula, okay, because that's what we're going to use in this video. Okay, so what we can do is we can replace this cos with these t's. Okay, so what we're going to do is say equals 1 over 4 plus 5 multiplied by 1 minus t squared on 1 plus t squared. Okay, and here there's a dx, right? So since I'm replacing everything with t's, we're going to need to get a dt. Okay, one thing I'll do is I'm just going to change all these thetas to x since our question has x. And let's try to differentiate this one. So dt on dx equals to, now hopefully you remember how to differentiate tan. If you differentiate tan, we should get sec squared x on 2, and we're going to have to apply a chain rule, so half at the front. Okay, now one useful thing is there's an identity involving tan squared and sec squared. Actually, there's the main one really. The first identity you should have learnt at the beginning of trig is this: sine squared plus cos squared is equal to 1. And to get the other version of this guy, we can divide everything by cos squared. So if you divide cos squared, divide cos squared, divide cos squared, then here you get tan squared plus 1. And 1 over cos squared, we can say, is sec squared. Okay, so you can see that we can replace, we have sec squared here, and we have an identity to replace the sec squared with tans. Okay, so I'm going to say equals to half. Sec squared is the same thing as tan squared plus 1. Okay, so hopefully that was understandable. I'm going to rub this and rub this out. So why did we just change it to tan squared? Well, because we actually have this substitution where tan is equal to t, right? So we can say half tan x on 2 is equal to t. So that means this is just t squared, right? And after you do a lot of T formula questions, you should hopefully know that this is the result that you would get if you were to differentiate it. Okay, so what do we actually want? We want to make dx the subject. So this was dt on dx, right? So if we just do a bit of arranging, we get 2 dt on t squared plus 1 is equal to dx. Okay, so now that we have dx, we can replace this dx with, let's use a black one, 2 dt on t squared plus 1. Okay, cool. So now we have everything set up in terms of t's, and we can just try to integrate this guy. Okay, so let's say equals to all over 2 dt now the way I'm going to multiply this is I'm going to multiply 4 by this first, okay, and then we'll multiply this by that. Okay, so there's like a bracket there. So we have 4 t squared plus 4. And if you have a look at this, t squared plus 1, and we have a denominator of t squared plus 1. So those should just cancel, which means we just have 5 and this numerator. Right, which means we'll have 5 minus 5t squared. Let's simplify the bottom, and let's bring the 2 out at the same time. dt. What have we got? 9 minus t squared. This is what we have. Okay, and then we get down to this. So 1 dt over 9 minus t squared. How do we integrate this? So this is the last I guess, bit of math we need to do before we get to the answer. We're going to factorize the bottom and say it's a difference of two squares, 3 minus t and 3 plus t. And we're going to do a little technique where we kind of split this fraction into 2. Okay, so to illustrate that, I'm actually just going to rub this out. Okay, and I'm going to show you something here. I'm going to say let 1 over 3 minus t, 3 plus t, is equal to a on 3 minus t plus b on 3 plus t. Okay, so basically what I'm doing is for a particular integer, or a particular number, sorry, a and b, there must be a particular number a and b such that if you were to combine these two fractions together, we were to get this left-hand side fraction, right? So this is a really useful technique if you want to split up this big fraction into two separate ones. Then we can kind of work out what these numerators were to be. Okay, so one thing we can do is we can make the common denominator on this right hand side and say a 3 plus t plus b 3 minus t all over 3 minus t 3 plus t. Okay, now we can notice that the denominators are the same, right? Which means we can cancel them out, which means we only need to consider the numerator being equal. Okay, so what we can say is on the right hand side we have 3a plus at plus 3b minus bt, and this should equal to 1, right? That's just the numerators being the same. And one thing I'm going to do is I'm going to group 3a and 3b together, and we have at minus bt, right? I'm going to factorize a t out, and we have a minus b inside. Okay, so remember these numbers a and b, they are just numbers. Like I said, they are not, they're not a prenumeral like t. Okay, we're trying to find what these numbers would be. So on the right hand side, we have just 1, and we can think of it as this is 1 plus no t's, like 0 amount of t's. So we can kind of use this to compare the fact that 3a minus b, those are the numbers, so that should just equal to this number 1, right? And since there is no t's, since there are like 0 t's, that means this t guy, a minus b, the coefficient, that should also be 0, right? So we can equate this together now and say 3a plus 3b is equal to 1, and a minus b is equal to 0. Okay, so hopefully you followed along up to that point, because we're right at the doorstep. So now it's a pair of simultaneous equations, which are actually really quick to solve, because on the second one, if we have a minus b is equal to 0, then that means a is equal to b, right? Which we can just sub in to this and say 3a plus 3a is equal to 1. So 6a is equal to 1, a is equal to 1 on 6. And since a and b are the same thing, b is also equal to 1 on 6. Okay, so finally, we found these numbers, a and b, right? So what can I summarize? I can say, let's just grab this guy, copy, and paste. So we can say, let's change this back to black. Since we now found a and b, we can say, oh, it's equal to 1 on 6. Actually, let's write it like this. 1 on 6 outside of 1 on 3 minus t plus 1 on 3 plus t. Right, so since a and b, they are the same thing. They are just 1 on 6. I just kind of pulled it out. I factorized it out to the front. Okay. 1 over 3 minus t and 3 plus t. Okay, so we did the bulk of this question now, which was to split this fraction up into two separate fractions. One good thing about math is you can always check yourself if you did this process correctly. Like if you were to combine this with a single denominator and put the two fractions together, you should end up with this left-hand side, right? Like objectively. Okay, so we're going to go back to our question where we had over here, we had this ugly fraction, and so we split this guy into here. So now let's write it again. There's 2 over 6, I'm just going to pull the 1 on 6 to the front, and we're going to integrate 1 minus 3 minus t, and 1 over 3 plus t. And we're going to integrate this guy. Now when you see any fraction that has a degree of 1 on the bottom, this is something that should ring a bell, and hopefully you can recall that we're going to use the ln, like the log, how to integrate logs. Right, so one thing the first one needs is a negative. So I'm just going to move this a little bit over here and say, actually, let's just write out the whole thing again. 1 on 3, I'm going to factorize a negative. Negative 1 on 3 minus t minus 1 over 3 plus t. Negative 1 on 3. I'm just going to apply the negative on this numerator to the bottom, which means we can swap this around, t minus 3. And just to make the right one look nice as well, let's just say t plus 3. Okay, finally, this is just ln t minus 3 minus ln t plus 3 plus c. Right? Alright, you guys can move a bit over here. And that's pretty much the answer, but let's just make it look a little nice and say a third. You know what? Let's just change this again. Let's apply the negative back in. And last thing is ln t plus 3 divided by t minus 3 plus c is the answer. Okay, so there were a lot of algebra things that were involved, especially this one here with the two fractions. But hopefully you understand and you can see the idea behind it, okay? Because once you get the idea, then the algebra is just up to you. Okay, so hopefully that was helpful for this integration question. Quite lengthy.